Massive solar wings create the illusion of a giant windmill in space, spinning 5,000 kilometers above Jupiter's clouds. It's not the first time NASA has turned to solar power, but it is the first time solar panels have been deployed on a spacecraft so far away from the sun. The director of planetary science for NASA, James Green, says by the time Juno reaches its orbit around Jupiter, it will only receive about 400 watts of power from its solar panels.
Now, that's just a matter of a few 100-watt light bulbs when you think about it. So all the experiments have to be tuned to be able to use that in an efficient manner. And the solar panels are enormous. And if you can think of a 16-wheeler, the side of one of these big tractor trailers, it has 3 wings that would fit along one side of a tractor trailer. And that's the kind of power it needs to be able to go all the way out to the edge of the solar system at Jupiter to be able to make these measurements.
Despite the small amount of power being generated, Green says Juno will be capable of some very sophisticated imaging and measurements.
It has fabulous cameras on it in the infrared and in the ultraviolet. So it will be able to peer inside the cloud structure, look at how much heat is actually coming out from the center of the planet. It will also map the auroral zone. Now, the aurora on Jupiter is absolutely phenomenal. It has the most intense aurora in the entire solar system. So we'll see where the particles are accelerated, where they rain on the upper atmosphere coming down the complex magnetic field that's generated by Jupiter, and look at that interaction between the atmosphere and these high-energy particles that are raining on the upper atmosphere of Jupiter, creating the aurora.
Green says Juno will be able to measure plasma waves and electrons and high-energy protons, the kind of stuff a planetary scientist would like to know about. But understanding Jupiter may also be the key to understanding our solar system. Scott Bolton is the mission's principal investigator from the Southwest Research Institute in San Antonio.
We're kind of going after this recipe of how planets are made. We're back at the ingredient list. We're getting the ingredients of Jupiter. We're going to understand what the structure is like inside, how is it built, and that'll kind of give us guidance as to what happened in that early time that eventually led to us.
It may be a while before that information is available, though. The solar-winged probe will take 5 years to reach Jupiter.
So once we get it up, we unfurl the antennas, and then we'll spin it. And it goes around once every 2 minutes. Now, the solar panels have to constantly point towards the sun.
But Juno will only stay up about a year. Green says after that, it will make a purposeful crash landing on Jupiter to prevent it from colliding with any other satellites. Rebecca Ward, VOA News.